Lesson 6.4, graphing trigonometric functions. The lesson, just a short lesson. The focus today will be sketching the graph of y equals sine x, y equals cos x, and y equals tan x, and determine their characteristics. As a background, you have to recall your unit circle, and your unit circle is based on a circle with radius 1, and we also refer to our reference triangle, 45 degrees, and we have them both in radians, pi over 4 or 45 degrees, or 60 degrees, pi over 3 or 30 degrees. We're going to use the concept of what we know about a unit circle to sketch the sine graph and the cosine graph. So this will be our reference point, really. So we've done this, and it's at the back of your exemplar booklet. So I'll be referring to this, so you should have this handy with you, or you probably could look at this. So this would be our unit circle. The angles 30, 45, 60, 90, 0. So it's repeated, except that the sign changes. Remember our cast rule. Cosine is positive here. All of the trig ratios are positive in the first quadrant. Sine and cosecant positive here. Tan and cotangent positive here. And cos and secant are positive here. So we look at sketching the sine graph, what it looks like. And from this, we'll discover a number of things. One, you'll discover that a periodic function, which is a function that repeats its value in a regular interval over time or over its domain. We look at the period. The period is the length of each interval. Then we also look at the amplitude. The amplitude is from the midline. The midline is the point that's between the maximum and the minimum value of your periodic function or sinusoidal function. And we also look at the domain and range and x and y intercept. So let's look at the first one. We're going to sketch y equals sine graph. So let's zoom out here a little bit here so you can. So we'll graph the sine function. And by the way, this is in your booklet. If you look at page 4, now I'm looking at this one, chapter 6, part 2 for trig. Now in this booklet, you'll find the exact chart there. And what you'll want to do is to review the definition of amplitude, period, phase shift, periodic function, sinusoidal function. We'll go through each one of these. And what you want to do, you can follow through and practice on your booklet. Now, I'm going to use this guy here, keeping me handy. So let's look at our sine function. So we'll complete the table using our unit circle. So when x is 0, I'll get it here, let's go back here. So when x is 0 for sine, so we sine x. Remember, this is going to be your cos, and this is your sine. So the x value is your cos, and the y value is the sine. So for the first sine, we'll be using the x values throughout. Now we are looking at radians measurement. We're not looking at degrees in this case, right? We're looking at radian measurement, radian. So in this, so we switched from degrees now, and we're going to look at radians. Now, so sine 0 is 0. So sine 0 is 0. I'll refer to sine pi over 6 is a half. Okay, I'll move up here. So maybe I'll zoom out so you can see both of these. So I'm using the first quadrant for now, and so pi over 6 is a half. So put a half here. Oh, and we will graph it later on. So first of all, we have and we're working all the way to 2 pi. So we'll repeat the cycle. So pi over 4, or this root 2 over 2, or 1 over root 2. Okay, so we have root 2 over 2, or 1 over root 2. So if you 1 over root 2 also here. And then we have sine of 6 degrees, which is root 3 over 2. Now, half a pi, now this is pi over 2 here, which is here. Sine is 1. Now we're going to repeat the whole cycle again. We have, and there's the reverse. So now we're going to have two over 3 third pi, so which is root 3 over 2. And 3/4 pi will give us root 2 over 2. And you see the cycle repeats, right? Then we have, what next we have? We have now 5 over 6 is a half. And notice sine of pi is 0. Okay, so back out. Now we're going to repeat. It's going to be a different pattern now, but except now we'll have to change the sign. Now, for this one here, it's still also 1 over root 2. If you want to get rid of that. Over root 2 over 2 is the same as 1 over root 2. So it's 1 over root 2 also. Now, 7 pi over 6. If you go back to our graph now, is negative a half. Okay. Remember, your x value is your sine, and this is your cos. So those give us negative a half. 5 pi over 2, which is, now you can notice, right, it's going to be the repeat of root 2 over 2. But in this case, because sine is negative in this quadrant, and these two quadrants, so they'll be negative. So all sine will be negative throughout here. So we have negative 1 over root 2, then we have negative root 3 over 2, or this is root 2, negative root 2 over 2. Negative 1, 5 pi, negative root 3 over 2, negative 1 over root 2, negative a half, 0. Now I'm just transferring it from here. Okay, so you see in the circle. Now we are going to graph it. So x is 0. So first point here, pi over 3 is approximately, now we have half a pi. Now, so these are all, so we have 1/3. Now, we have 0 here. So pi over 3 going to give us approximately, so pi, half a pi, so it's right here. So here's my pi over 2 here. and that'll be 1. So it would be pi over 6, pi over 3, pi over 2. And we have actually pi over 4 here. So pi over 6 here. And this is pi over 4. So 2/3 pi. Okay. So you have 1 of pi over 2. So pi over 3. Here we have pi over 6. So graph these. And so notice my maximum here is 1. So pi over 2 is 1. And over here, negative 1. 1.5 pi, which will be here. So you notice here we have 2 complete cycles. So this is y is equal to sine x. Our domain, in this case here, is from 0 to 2 pi. So x is between 2 pi and 0. For range, ranges from -1 to 1. The x-intercept are 0, pi, and 2 pi. Zero, pi, and 2 pi, and the y-intercept is 0. Now, that you can practice in your example booklet. So you can duplicate it on this graph here. Now, what's the maximum value here? The maximum value here is 1. So we can put here maximum value 1. The minimum value here is equal to -1. Okay. We have domain, so our maximum minimum value, and our amplitude now. The amplitude is the distance from the midline. This is called the midline here. Now the midline is the line is called an average. It's between the maximum and the minimum. So your maximum is 1, minimum is -1. So the midline is the line that's separate, that's between the maximum and minimum. Now the amplitude is from your midline to the maximum or the midline to the minimum. So the amplitude, which is basically the maximum minus the minimum divided by 2. So in this case, it's going to be equal to your maximum minus the minimum. You have 1 minus the minimum, and that will give us 2/2. So we have the maximum is 1 minus -1 over 2 will give us 2. Oh, sorry, 1. And you can tell it's from this point here to 1 here. So visually you can tell that is, but algebraically you can work out the amplitude. Now let's look at the cos. I'm going to repeat it. For cos, same thing we've done for this. Now in this case we will look at the cos. Okay. And again, I'll refer to the unit circle, but this time we're using your x coordinates for the unit circle. So cos of 0 is 1, cos of pi over 6 is root 3 over 2, cos of pi over 2 is root 2 over 2, cos of pi over 3 is a half, and cos of pi over 2 or 90 degrees is 0. And then it repeats, except now in the quadrant 2, cos is negative. That's why you have negative a half, negative root 2 over 2, and negative root 3 over 2. And pi, cos of pi is negative 1. Also in quadrant 3, cos is negative, but it's also is positive in quadrant 4. So we'll repeat a pattern here. So we have 1 root 3 over 2. You have 1 over root 2, half, 0, negative 1, root 3 over 2, what would that be? Sorry, 3 pi over 4. That will give us negative 1 half. Sorry, 1 over root 2. And 5 pi over 6 is negative root 3 over 2. By the way, this could be also root 2 over root 2. Sorry, root 2 over 2. Here, this is negative 1. And 7 pi over 6, just for make sure you like 7 pi over 6 negative root 3 over 2. By the way, the way to remember this, once you know one quadrant, it's repeated for all the other quadrants, except the sign changes. So it's a repeated pattern, right? So for example, pi over 6, and you find the cos is root 3 over 2. But look at the reference angle here is 30 degrees, or 5 pi over 6, which is 1 pi plus pi over 6. It's equal to root 3 over negative root 3 over 2. So this is sign changes. So we have negative root 3 over 2, negative 1 over root 2, negative a half, 0, a half, 1 over root 2, or now it's positive in this quadrant, it's quadrant 4. Now we in 1. Now we're going to sketch this now. And here's the difference between the cos and the sine. Remember your sine x is 0, sine of 0 is 0. But now cos of 0 is 1. So now we're starting from here. Now pi over 2 is 0, which is down here. And then pi is negative 1. So this graph is actually going down. And plot the points. What's half? And then it will repeat now. We have 3 over 2 pi, which would be right down here. This graph goes up here. And now 2 pi is equal to 1. So the domain x is between 0 and 2 pi. So we're restricted it to 2 pi. But you realize this could go on to infinity. We're restricted. The range is from -1, which is our minimum value, to the maximum is 1. So y is between 1 and -1. The x-intercepts, now this is where it's different from the sine graph. The x-intercepts, what are they? They are pi over 2 and 3 pi over 2. The y-intercept is at 1. Now, the amplitude, in this case, we're going to look at the amplitude similar to what we did there for sine. The amplitude is 1. Now, one thing we didn't look at is the period. Now, the period is one cycle. In other words, the interval between if we have here, from here, we start here, where does it repeat itself? Where is it complete? So here we have, if you go back to your sine here we start from here, come back, and repeats. So the entire period here is 2 pi. Okay, so that's your domain from 2 pi. So this is the period. It's equal to 2 pi, the length, right? So the period, or the length of each interval. So the length of each interval. So you start from here, maximum, and it ends here. So the length of this interval is called a period. So the length of the interval, and it's measured along the horizontal axis here, right? So in this case, it is 2 pi. What is the measurement also of the cycle? So the length of each interval measured along this x-axis here, or the horizontal axis, is the period. In this case, is 2 pi. Now, the last one we'll do today, and we'll see the pattern here, is for tangent. Now, tangent is a little bit different because if you look at your periodic chart here, sorry, not periodic chart, your unit circle, you find there's no indication of tangent. But remember your tangent, what it is. Tangent is sine over cosine, or y over x. So for each one of these here, we can, so in this case, it would be half over root 3 over 2. But if you look at tan of 0, it is 0 over 1. So for example, tan of 0 degrees, or 0 in radian, is 0 over 1, which is y over x. So pi over 2 tan, so pi over 6 tan, pi over 2 tan is a half, right, divided by root 3 over 2, which works out to be 1 over root 3. So now tan of 45 degrees. Now, recall we did that earlier in our chart here. We have tan of 30 degrees is root 3, or 1 over root 3. That should be there. So tan 30 degrees, or pi over 6 here, it's 1 over root 3. Right. So tan, we have 60 degrees, or tan pi over 3 is equal to root 3, and tan pi over 4 is equal to 1. So we can transfer those to our unit circle here, but in this one here. So tan, which if you want to change this around, we put here tan 0 is equal to 0. So tan 30 degrees, or pi over 6, we can change this all over. So 1 over root 2. So tan is 1 over root 2. And 45 degrees, we know tan is equal to 1. And tan pi over 3 is equal to root 3. Now, tan pi over 2, which is 1 over 0, this is undefined. So using these, we can repeat the pattern for tangent. So we'll do a tangent one. So tan of 0 is 0. Tan of 1 over root 3. Pi is 1, root 3. Now 90 degrees, we say it's undefined. Then we have negative root 3, which is a repeat now. Negative 1, repeat the pattern. 1, negative 1 over root 3, because this is quadrant 2, and this is 0. Now, in quadrant 3, it means this is positive, right? So 1 over root 3, 1 root 3, undefined. Here we have negative root 3. Now in quadrant 4, it's negative. Now, what you want to do, first of all, is to put an asymptote where it's undefined, so pi over 2, which is right down here. So pi over 2. So we have an asymptote right there. It's undefined. Then it's also is 0 at 1, and it's also undefined at 3 over 2 pi, which is right here. So I'll just put it here at the bottom here. 3 pi over 2, and this is pi over 2. So it's undefined. Now, if you go to x is 0, then we have 1/3, and pi over 3 is root 3. So now this goes on for just somewhere above here. So graph goes up. And now it crosses at pi here at x is 0. And then it goes down here. So notice this graph goes up. And finally, I'll put too much here. So there's no, the domain doesn't exist at pi over 2 or 3 pi over 2. So it's everything except for those 2 points. So the domain where x is not equal to pi over 2 and x is not equal to 3 pi over 2. The range, there's no limitation to the range, right? It's from negative infinity to infinity. So we can say y is a set of real numbers. The x-intercept are 0, pi, we have 0, pi, and 2 pi. Y-intercept is only 1, which is 0. Now the asymptotes are pi over 2 and 3 pi over 2. So here, x equals pi over 2 and x equal to 3 pi over 2. Now there's one last question we'll look at here. And it says here, explain how to extend each graph from x greater than 2 pi for x less than 0. Now, for any angle, right, if you're going to go for any of these graphs, for any angle where x is greater than 2 pi or x is less than 2 pi, the value of the trig ratio equal to the value of the coterminal. So it's all the remember there's infinite number of coterminal, so it's repeating. So the value of its value is equal to the coterminal angle between 0 and 2 pi. So it repeats. So if I were to put that in words, so for any angle where x is greater than 0, or so x is greater than 2 pi, I should say. So we're looking at more than 2 pi. X is greater than 2 pi. Or even if you look at our sine x here, so this is, well, I should do 10x, where x is greater than 2 pi or x is less than 0, because we're looking at going this way here. The value of a trig ratio is equal to its value for a coterminal. So in other words, if you're going to go repeat beyond the x equals 0, you repeat the pattern you have for pi going to the coterminal pi angle in the domain x between 2 pi and 0. So in other words, the value in each table will repeat. So the value in each of these tables here will repeat. So whatever value you have here will repeat. If I were to continue now into 2 pi plus like pi over 6, it becomes 1/3, etc. Like 2 1/4 pi, 2 1/3 pi, right? 2 1/2 pi will be undefined. So the values in each table will be repeated. And the graph will repeat, right? And the graph will repeat. Okay. If you want to try for assignment questions, you can try this one's here. But I want you to mainly focus on, just go over this ones in your booklet. And this is your part 2 example booklet. I would like you to repeat this on your own. So try, this is sine. And here we have one for the cos. And the next lesson, I'll be looking at in more detail the characteristics of a sine function and the characteristics of a cosine function in detail. So to conclude, our goal today was to sketch a graph of y equals sine x, y equals cos x, and y equals tan x, and determine its characteristics. We look at the maximum value, minimum value, the amplitude, the period, the y-intercept, domain, and range. And your assignment is to practice sketching of the sine and cosine graph in your booklet.